Okay, fourth graders, today we're continuing on with Module 6, Lesson 2. And today we're going to continue to use metric measurement, and specifically today we're going to be talking about meters and centimeters and millimeters. And we're going to be using area models to represent tenths as fractions and decimals. Really what this means is we're going to continue practicing how we can express a certain measurement using fractions and using equivalent decimals. With your ruler, please draw a line segment that is 2.6 centimeters. So you're going to measure with your ruler 2.6 centimeters. Okay. You're going to draw a line segment, and then you're going to label it as 2.6 centimeters. Then we're going to express it as an equivalent mixed number. What's the whole number part of 2.6? Everyone? 2. What's the fraction or the decimal part? 0 point. That's the same as, how do I say 0.6 using unit forms? It's 6 tenths. So I can write it as a fraction like this, 6 tenths. Okay, so today we're practicing how to write decimals as equivalent fractions, because every decimal can be written as a fraction, and every fraction can also be written as a decimal. How can we write 3.5 centimeters as an equivalent mixed number? What's the whole number part of 3.5? Haruto? 3. What's the decimal part of 3.5? Sanvi? 5 tenths. So we can write 3 and 5 tenths. Remember, a decimal is something less than 1. A fraction is something less than 1. They are the same thing. Okay, try the next one. 1.7 centimeters. Don't worry about that extra C, that's a typo. See if you can use your ruler to measure 1.7 centimeters. Of course, then we'll label it. What's the whole number part of 1.7? Remember, a mixed number has two parts, a whole number part and a fraction part. Avani.
The whole number part of 1.7 is 1.
Very good. What's the decimal part, Avani?
7 tenths.
7 tenths. So how can I write it as a fraction? Well, I just write 7 tenths. So every decimal can be written as a whole number, or sorry, as a mixed number or a fraction. What? Every fraction can be written as a whole number or a mixed number. Every decimal? I don't know. Anyway, you can write them as both. Good. We can also use pictures to model decimals and fractions. From now on, whenever I say decimals, it really just means fractions too. In fact, the unit module 6 is called decimal fractions because they mean the same thing. Okay? So if I have 2 ones and 6 tenths, just watch. You don't need to draw all these things. But give me instructions. How would I shade in 2 ones and 6 tenths? Well, what's the whole number part? 2. So I'd shade in 2 whole boxes. 1, 2. Now, each whole has been divided into 10 equal sections of this area model. So if I want to show 6 tenths, how would I shade in 6 tenths? Well, I'd shade in 6 of these tenths. 1, 2, 3, 4, 5, 6. So now I've shaded 2 ones and 6 tenths. Using fraction form, we can see that 2 ones, that's 2 wholes, and 6 tenths, that's equals to 2 wholes, here's the 2 wholes, plus the 6 tenths. Using decimal form, that's 2 wholes plus 6 tenths, which equals 2.6. Does that make sense? Let me ask you a question. If I wanted to add something to 2.6 to make it the next whole number, what would the next whole number be? What would the whole next number be? Next whole number. Garrett? 3. Okay. So what do I have to add? What's missing? Well, I would have to fill in this section right here to get to 3. What do I have to fill in to get to 3? Kaship? 0.4. Is there another answer that would also get me to 3 besides 0.4? Kaship?
4 tenths.
Good. 4 tenths equals 3. This is kind of like thinking about those benchmark numbers. Do you remember in 1st and 2nd grade when you would see the dot grid and you would see 6 of them colored in, and then your teacher would ask you, how many more does it take to get to 10? And you would say? 4. Good. Do you guys remember that? Trying to find fact families that add up to 10, that will really help you here. You have to always be ready to think about what's missing. How many tenths do I need to get to the next whole number?